Hello, everybody, and welcome to Handmade Heroes, show where we code a complete game live on stream. I kind of realized after yesterday's stream, I was like, you know what? I'm putting the cart before the horse here, and I realized that we had already optimized that part of the code that we were looking at, the specular to diffuse transform. We'd already kind of gotten that down to a fairly low amount of work, and although we could lower it further to be certain, I think, it was probably the wrong time to do it. So if you take a look at where we're at currently in our lighting experiments here, you can see we've gotten this down to 12% of the total time, and the cast is still at 80%. So I was thinking probably at this point we're gonna have to start looking at the casting a little bit more aggressively, and that's probably what we should be focusing on rather than what we were focusing on, which was further optimizing that particular piece of the spec diffuse transform there. So we should probably do that, and that's what we should probably start looking at today, because that's going to be the more important thing to look at. Now, the other thing I realized is that if we go into one of our largest rooms, which is here, I also think probably at the very least, if we kind of pull back on this and take a look at where we're at, we probably have a lighting box that is maybe also still a little too big. We could probably shrink the lighting bounds down, because this is the largest kind of view we'll ever have, is like this. And this is still probably larger than we need it to be, especially if we slide it along. And so we may also be able to say, look, in terms of the total amount of space that we need here, we might also be able to, even at the same resolution, drop the total amount of lighting region down a little bit, right? That, or we can change the size, right? And so maybe the thing is, maybe this is something we should still strive to do about this much, but we could make the size smaller. So for example, if we go into the lighting code, and we look at how this is being aligned, so we look at how we're actually building up the region where this is going to be, then in here, we can sort of say, well, we could make it, we could shrink this down by 2 or something like that, because it does have to currently be aligned to the world. So it could be some other multiple of the world, or we could also just make it be less. And I don't know which one we want to do. But, for example, I could imagine dropping this down, or even dropping just the Y. So you could imagine doing something like this. And if we did something like this, where we were 32, 24, 16, so where the Y is actually a little bit different. And I don't actually know, we've never tested changing those two, so we don't actually know if there's bugs in that as well. But if you look at the effects of that on runtime, you can see that the more we drop that down, the closer we get to 30 frames a second. And the closer we get to 30 frames a second, that's a shippable frame rate. And it also gives us a lot better chance of optimizing to 60, right? So if we take a look at how that fits the region, it fits the region still pretty good, right? And so, we can continue to shrink this down and have, we can continue to make this fairly, tight as a bound on the world, and I don't think that there's much of a problem with that. So we may want to just keep that bound as tight as we can, because again, that just improves our chances of getting a good frame rate with quality lighting, because the less lighting we're computing every frame, the better, and off we go. So what I might want to do now is say, all right, let's try to actually position this thing around the actual view. Right? Because right now you can see the views sliding around, this is what we'd be seeing in game, and as the view would be sliding around here, this is not moving at all, right? So what I might want to do is go in here and say, inside the world mode, let's try and draw the camera focus point, where we're actually, let's try and figure out what are we actually looking at here frustum wise. And see if we can figure out how to bound the lighting, align the lighting as closely as possible to what we're actually going to see, because that's pretty important, right? So if we take a look at how this is going, you can actually see here that there's some stuff that's if zeroed out regarding that, right? Here's some light bound nonsense, right? You can see here we were doing some things here, right? So at the moment we're doing the light bound stuff. inside the begin lighting computation entirely, but before we had done some things here that was related to it, right? And you can see we have a world camera rect that's being sort of get at here, which is the get camera rectangle at target. And so what I'd like to do is resurrect at least just that one part of it there so that we can maybe start to see about where are we actually looking. So I'm gonna try and get this function working better, because I don't think we ever really got it working. And so what I'd like to do is pull out what we think this camera rectangle actually is and just draw it. And then I'm gonna try and get the lighting bounds to chase that visual rectangle more closely. So if we take a look at the push volume outline call here, right, you can see that we're drawing the hot voxel rect in here. I'm gonna also draw at the same time, I wanna draw the visible rectangle so we can see that one too, right? Okay, so in here, right before we do the lighting computation, and again, these colors don't actually work because we don't have a way to turn off lighting at the moment. Eventually we will. We haven't gotten there yet. So we're gonna go ahead and push a volume outline here. The hot voxel rect is not what we want to draw. Obviously, what we want to draw is that world camera rect. And what we want to do is take the world camera rectangle. Oh wait, we need the focus Z there. And you can see this is probably garbage. I don't know, maybe it's not, but we'll see in a second. So what we want to do is take that camera, figure out where it's looking, and try to actually get an accurate picture of what we're actually seeing. So here's me drawing that, right? And now you can see, like, as I move around, you can see those bounds moving with me. And the problem that we have now is I don't know that these bounds are particularly accurate, right? And so what we need to do now is figure out how to make that be really closely tied to where the screen is. So let's actually see if we can do that. So you see right now, you can see how it's actually, like, it's sort of correct in a sense, but it's a little bit under, like, it's a little bit not conservative. We need something conservative, I guess is the word here. We need something that we can never actually see this part of it. So it's not giving us a large enough screen rectangle. It is now correctly moving with us, so we've got that part right. It does appear to be locked to the camera position, and that's great. But what it doesn't seem to do at the moment is actually kind of give us the size. Now, one thing I guess, now that I think about it, is since we can't change the size of the lighting thing, maybe I actually don't care. I guess we only really need the centroid of this thing, right? So I guess actually, now that I think about it, I don't have to really modify that. What I could do is say, look, we know that the world camera rect actually does give us a center okay. So maybe that's all we need. Seems likely. So I'm going to go ahead and say, all right, in here we've got a world position for the origin P, and then we've got this camera offset from origin that we're passing down. And I guess when we get this world camera rect here, that is giving us a good enough piece of information there. So I guess we don't really need to pass this down. The camera offset from origin is not being used at the moment, right? Yeah. So we could say, like, camera center from origin, something like, I don't know, camera center offset, something like that. And then what we can do is just pass down the center of this thing. So we can just say, all right, we'll pass simulation center, get rid of the delta from sim, and we'll say get center, like so. And we can just pass the center of that bounding box. And that could give us where we want our lighting to be centered. So now one thing we could do is just use that center immediately, right? We can do that. But the problem is if we do that, we don't actually have, excuse me, we're not actually aligned to the world. And what you can see here is we need to be able, or I shouldn't say aligned to the world, we're not aligned to, like, chunks. We need this thing to be aligned because otherwise, as it slides, you would see the lighting kind of slide across the cells in the world. So we want it to move by, like, entire voxel cells. You know what I'm saying? And I guess to a certain extent, I'm not really sure why we cared that it was aligned to the world per se, but we might want to keep that for some reasons about, like, light leaking and so on. We might want to make it so that we're always sort of snapped to the world grid as well. So I think we probably do want to keep that. But what we don't want to do here is this sort of stuff here where we do the center moved thing. I think that now this whole thing has to get, unfortunately, a lot more complicated. So we do need to know like all of this information, and we do need to do all of this work, but we have to take our inputs where we're actually going to be moving. We have to be a lot more granular about how we're moving. We need to move by world tiles, probably not world chunks. That would be my assumption. So we need to actually be like very specific about how we do this. That's my thinking. So probably what we want to do here is just say, all right, we've got the origin P, and we know that that's going to give us an offset. And we probably need to do the center moved stuff basically every frame. Now, not every frame, but anytime the camera moves, so it has to be a per frame thing. It means that there's a lot more pressure on block copy Atlas, certainly, and we're gonna have to make sure that that routine is nice and quick. But hopefully we can make sure that that's the case. So what we need to do here is say, all right, this idea where the center, like this part here, is now not sufficient. This is actually going to be something different, which is like chunk moved, right? And chunk moved is going to be one way in which we can have a displacement. But another way that we can have a displacement is if the camera center offset changes enough as well, right? So the first thing we want to do is say, all right, voxels per chunk is always on the table because we're going to need to know that piece of information. Well, okay, that's not actually true. I take it back. I suppose we only need to know that if this happened. So, all right. So if we have an origin change like before, we do need to adjust for that. So that's fine. And we do have like a de-origin chunk sort of operation that's happening here, right? And so we're going to want to do some kind of a summation where we say, all right, we've got a something like dvoxel, right? And it starts off at nothing. And in this particular case, we then know that we're going to have to take our dvoxel and add to it however much the offset would have been for this, right? So we need the chunk moved to occur properly, and we need that to do this, right? And I guess I don't know that we need to save this variable either, so we could probably just make this a little simpler by saying, look, let's go ahead and just make this path happen whenever this is not true. And then once that's done, once this has finished, then we need to say that from there, we need to adjust for the camera center offset, right? And at the end here, where we have dvoxel, really what I want to do here is just check to see if any of these are non-zero. So all I'm doing here is saying, all right, let's break this up into two stages. One that does the offset for the center, and one that does a check to see if there was any changes, and then does the block copy. And that will set me up in here for adding an additional way of sliding the voxel around that's based on the camera position. So let's take a look at what we need to do here. For dvoxel, this is the origin chunk. And it looks like we don't have a plus equals. Is that true? Yeah, it's true. And so that should just work the same way. There shouldn't be any difference. So if we take a look at what happens now, that hopefully nothing like broke, right? And it looks about right. Those copies, like the lighting there, stayed stable as it moved, right? So that seems fine. And then what I need is I need to be able to, and I may have been premature about this because we may need to do the second part as well, but either way. Sorry, my eye's itchy. Allergy season. This is why I can't go outside. I have such itchy eyes. I would definitely get the coronavirus. Anyway, so basically what I need to do here is I need to say if the camera center offset was different, I'm going to have to also account for that. So we need to take a look at the camera offset center and see if that meaningfully changed one way or the other. Now, I don't actually know how we should do this exactly, because we kind of also need to track what this offset would be. So I think, I guess what we'd probably want to do, yeah, I think I was premature with this. I guess what we'd probably want to do, the easiest way, I think, to do this, and maybe we'll see an easier way to do it in a second, but we probably want to do an if center changed and then process the center change and then do a if center changed like or kind of a thing where we compute a voxel offset if the camera center offset changed, right? And then we'd do something like this where we'd account for the change here. So let's see what we would need to do there. If the previous voxel was centered around a particular camera center offset, all we really need to do is figure out like how many voxels we need to offset to get to the current camera center. And that should be pretty simple, right? It's just yet another, flooring function probably, or we can do a rounding function, doesn't really matter. But basically what we would say is like, the camera, the camera offset or chunk or, voxel camera offset, something like this, is going to be the camera center offset. And it's going to be using the sort of inverse of the voxel cell dim. So whatever the voxel cell dim was, and I thought we had an invox cell dim here. Am I wrong about that? So we have an invox cell dim. Why is this a divide instead of a multi? Why not use invox cell dim here? So this is, I don't know what's going on here. We probably just didn't have the time, or I forgot, or I don't know what. But we can just multiply by the invox cell dim. And then basically the round of that, right? And I assume we have, no, we don't actually. All right. So I'm going to go ahead and see if we can't just add something that rounds a whole vector at once. Because if we have something that rounds a whole vector at once, then these equations get easier for people to read, right? So, like, for example, if I want to compute a V, oh, there it is. So we have a floor to V3S, right? So we should also just have a round to V3S. Like this. And then we can just go ahead and call that en masse. So this can just be, a simple rounding function. Round real 32 to int 32. Oops, nope, sorry. Round to V32S. So once we reduce this and say, okay, how many cells is it? We can then round it to an offset, and now we have however much the offset should be. And in this case, we would then add that to the total offset we need to compute. And this is the amount of movement that would be required because of that offset. And I guess now that I think about it, so I could oscillate back and forth on this. I guess if we just save the previous offset, we could look to see what the difference between the two values actually ends up being, and only produce a change if necessary. So I guess actually we really don't need this. So I guess we would just say, look, here's the voxel camera offset. We'd look at voxel camera offset here and say, if not are equal, then we actually do the difference. So in here, the dvoxel in this case is just the difference between these two, and off we go. Now, I think that also means we probably want an is 0, so we could be like a dvoxel camera offset, something like this, I guess, where we just say, oh, okay, what we really could just say if is not is 0, right? And that would just allow us to do a direct add. So we could say, okay, here's the old one. Here's the new one. That's the delta. And then after we're done, we just save it. And then we could just say, look, if there's any difference here, then we need to do the block copy. Otherwise, we don't need to do the block copy, right? Yet another way to look at it would be is we always do the block copy if the, we could actually just put an if here, if non-zero, but it doesn't seem worth it. So all I really need to do there is save whatever the voxel camera offset actually is, and then I think we're okay. Yeah. That seems right. Yeah. This has to be a Handmade product, obviously, because it's a vector product, and we don't actually assume that vector product is a particular thing. We don't know if it's a dot product or Handmade product or cross product, so we make you say which one it is. It's not the same as in shaders, but what are you gonna do? So yeah, I don't know that I thought that through properly, right? In fact, I think I probably didn't because I saw some flickeriness there. But let's just take a look at what happens first just to get a sense of it. You can kind of see there's a little bit too much jerking around there. So it looks like it's not quite, it looks like it's going like, rather than copying forward, it almost looks like it's copying backwards. Like maybe I did the math wrong or something. So I'm not sure exactly what's going on there. So if you take a look at what I'm doing, maybe we can see if there's a bug in there. In theory, this part of the code is not happening, right? So, in other words, if I just look at what's happening in, well, I guess that's big enough that the simulation center changes. So, but if I go to like, say, a scrolly room, so let's go over to here, right? So the simulation center now is not changing, right? The only thing that's happening is the scrolling is occurring, right? See? And so in theory, the first part of the code, this part of the code is not involved. So the only thing that's happening now is just this. And you can see here that this camera offset here is basically saying like, all right, hold on a second, let me take a drink here. So here we're basically saying, look, let's figure out how many of these there are. And we'll do a round, and that's where we'll put this thing. So the invoxeldim should tell us how many cells we want to get to the camera center. And then the delta between those, we're just subtracting like what that desired amount is versus what the amount we last applied was, right? And I can't see what the flaws in that logic. I'm trying to think. Seems about right. We then have the dvoxel, which is saying, look, this is the amount we're going to sum. So if we had any of that we needed to do, we're going to do it now, right? We then save whatever it was that we thought the offset should be so that we won't do it again on the next frame, right? And again, I can't really see why that's creating sort of the weirdness that I'm seeing. Because it should, I would think, just as it slides, if it's doing the correct copy, you wouldn't see any change at all, except around the edges, right? Because all it's doing is moving one cell forward and then copying one cell. But maybe I'm misunderstanding like what this actually means, right? Like, oh, you know what though? Here's the problem, is that the vox min corner is never actually, is not itself moving, right? So what we actually need to do here is take whatever the voxel camera offset is, like floored basically, and use that amount. So this voxel camera offset here has to actually be factored in here, right? Meaning we have to have this voxel camera offset here, however much we're moving, has to be taken into account. So so I guess what we want to say is that the actual starting location, right, is, you know, the negative of the origin here plus the voxel camera offset times the cell dim. Right? And I think that's correct. Could be wrong about that. What's the problem here? No acceptable conversion. Keep living in shader land. There we go. All right. So again, not quite what we would expect. Let me see. Am I thinking about this wrong? Let me also, I'm going to pull this out. So this is the origin offset for camera. Oops. There we go. And so, yeah, the center, we've moved by that much, so it should be negative as well, right? And so I think wherever the min corner hot is, it's going to be whatever that, you know, value actually is, right? Because that's the amount of delta that we applied. So let me just take a look at what movement is happening. If I actually run this and zoom out, I should be able to see, like, so it's actually going the wrong way. So I have this backwards in my head somehow, I guess, meaning that this value should actually be positive on the outside. And to be honest, I'm not really sure I understand why. I'll have to think that through. But basically what that implies is that it's actually going the other way. Let me just see if that's actually true. Yeah. So why we need to go draw this out on the blackboard, because I don't really get that. Like, these sorts of origin things are always very squinky, so I'm not surprised I don't get it. But at the same time, I want to make sure that I'm not missing some other thing, because if something goes the opposite direction, I think it means my mental model's wrong, and that's not great, right? Okay, so now if we actually go in here and look at the view, I'm hoping that we won't see a lot of lighting errors, visible lighting errors. And we'll see, you know, I don't know to what extent that'll be true, but we'll check it out. So we do see some weirdness here where we're seeing some like weird beat frequency out there. What's going on with that? So this is still like totally broken though to a certain extent. If this is the camera center, why is this so far over here? Like, that's just not the way that the lighting should be aligned, right? So you can see there's some other bug as well. Like, yes, it's moving, but it's not moving correctly. So yeah, it's still not centering the lighting region. So what am I doing wrong there? Because I'm obviously doing something wrong there. What's the deal with that? something's wrong. So there's a couple things that could be wrong now about it. In addition to the fact that this is not the sign that I thought it was, there's also the fact that I guess I'm not sure what happens when this changes, you know, and now we don't know what this offset should necessarily be. So I don't know, like, if it makes more sense to say, like, I'm curious, again, just exploring this. If I set this to 0, so that now it reapplies the delta, like whole cloth, basically. That shouldn't be right. So again, this is kind of me just looking to see, this is me looking to see whether I'm just like totally floating out in space with my conception of how this works. Because this should be worse, right? And if this is better, then that's yet another thing I don't understand. Yeah, so that's not better. Okay, good. Whew. So I only have one thing I don't understand. All right, so yeah, fundamentally right now, we're just getting some weird, like, I don't really understand where that, why we're not getting more of an offset on the lighting. Like, why is the lighting not sliding over in X, right? Because we want this to be the center, and this was the center. So we need, so the sign is wrong here. We want this to be the center, don't we? So let me think about how this is working here. So first of all, block copy atlas, I don't know what the okay, let's start from the beginning. I need to document what this means because voxel doesn't really make any sense. What does that mean? It's like, is it going to move it in that direction or backwards, right? And I don't know. All right. So if we look at what's happening here, and we want to do a copy tile, we copy from the voxel to where we are. So I think now we're sort of getting to the point where, which is what I didn't understand. So if we look at what's going on there, the voxel is actually telling us how far to grab the next tile from. That means that the entire voxel will actually shift by the opposite of voxel, right? So yeah, we got to start with that understanding. So block copy atlas really needs to document what this is. So this value should probably not be called voxel. It should probably be like fetch offset or something like that. So it's where you will fetch the voxel from when you're actually doing your delta, right? And that's why the copy tile here, right, is, look, I'm fetching from whatever this delta tells me to fetch, and I'm getting this, putting that in the destination. That means if you looked at the voxel and you were just like visualizing just the voxel, then if you gave it a plus X, you would actually see a negative X translation because it's fetching from the negative of that thing, right? So it's important to understand what this is, and I think we just want to make that clear. Something like that. And that way, we now have a comment in there that says block copy atlas does this particular operation, so we're not confused about what it should be, right? So dvoxel is basically, inverse dvoxel. I mean, I don't know how you want to look at that, but it's kind of a little bit, squinky. And I suppose calling it dvoxel is maybe a good idea at that point because it's like kind of an ambiguous term. And so it encourages you to actually read about what it's going to be used for. All right, so if we look here and we say, we know that the origin is getting displaced a certain amount. You can see that's why we're doing the subtraction in this order. It's because dvoxel itself is sort of inverted as to the direction the voxel will slide. So this has to be talking about the place you want to put the origin, which are going to invert the direction you would slide things. I don't know that that makes a lot of sense to do it that way, but that is how we were doing it, right? So then if we look at voxel camera offset, now we're saying, well, in addition to the location of the origin, we're also going to have to move around a thing that says where the camera is relative to the origin, right? And in theory, we could actually, I suppose we could make it so that we recompute. You know what? And now that I think about it, so here's a question for everyone. Do I even need to do this? So here's a question. If we go look at the world position, we have a way to canonicalize things. Right? So if we actually just used that, so we could just say, look, here's our world position, and we want to recanonicalize it, right? Couldn't we just do that? So like this call here, like this. Couldn't we just call that and not do a secondary one of these? I think I may have just done something stupid. So let's suppose we just don't do this. Any of this. Right? So let's suppose we actually did this. So we actually don't care about any of this stuff, right? Would this actually be sufficient if we just used the chunk space map? And maybe it won't be. Like, we'll check it out in a second. But suppose that that was all I did. So begin lighting computation, actually, when we call it, we just move the thing into chunk space first. So we say, get the center of the world rect. And we basically say, like, world position lighting center equals whatever the current simulation center is. We then say lighting center dot offset plus equals get center world camera rect. And then we just say, or actually, I guess we don't do that. Never mind. We just say map into chunk space. And in here, we put the get center world camera rect. So we just produce the lighting center as its own world position and let that flow through this. I don't know if that's resolute enough, but it might be, and then we wouldn't have to even have a secondary code path there, right? So I think that needs the world probably, I'm guessing. Don't actually know. Yeah. So I'm curious if that just solves the problem. It might. I don't really know. Let's take a look. Whoa. So again, really strange. I don't understand why that motion is happening counter. So we've got issues here. I also don't see why that whatever I just changed should have created that like making things brighter, right? Like what happened there? You saw what I was talking about. So if in here, if I literally just do this, right? Lighting is normal. If now I do this, lighting is nuts, right? So again, like something weird is happening here. I don't really know what. And so we've got a lot of issues now, and we need to figure out like what the heck is happening. At this point, that doesn't need to still be there. But we've got some really weird stuff happening here. So we've got bugs, and I guess this is good. We have a pretty obvious like test case where we can take a look at what's happening. But so in here in begin lighting computation, I want to go ahead and see like what's happening here. Because I guess this must be triggering more often. I mean, that's the only thing I can think of. Meaning if this is not happening, I'm assuming, what? This is crazy. So just the act of passing down a slightly different center made that happen. So we're in like Nonsenseville at this point. So we've got issues. And it could be this is, well, actually, no, I don't really know. So this is going to be interesting, and I guess we'll see. So here, let's go ahead and investigate further. So that's fascinating. And I have no idea what's going on. So I guess we'll learn something in a minute here. So if we have the lighting offset getting passed down on each frame like so, light fills up the entire area. Almost like there's a copy bug or something. Also, we can get rid of this. Let's suppose I turn this off. I'm assuming that now that it's done, it will never undo itself, but I don't even know that. And so the weird part about that is it doesn't even look like it's a materially different lighting scenario either, right? So let me just see what happens if I move this now. Does this shift at all? I mean, barely. That's a puzzler. Wow. That's just a real puzzler. I have literally no idea what's going on there at all. All right, so we're going to have to kind of dig in here and do some sleuthing, because that's just totally bizarre. I have no idea what that's doing, even a little bit. I don't know why those two things would be related, because, again, it doesn't really look like there's any particular way that that would affect the lighting. So something is super weird. Probably just have bugs somewhere that we are not catching, right? So let's just take a quick look here and see what's going on. When we look at like the cell count, all this stuff makes reasonable sense, right? We're just looking at how big the voxel itself is going to be. And when we're creating the rectangle itself, we're just producing exactly what you would expect. And then we're drawing it here, right? When we set the lighting bounds, we're just saying the region in which the lighting would occur. That doesn't really make much sense anyway. And I don't see anything weird going on there. So yeah, that's totally, again, I really don't see what's particularly weird about that. I don't really see what's particularly weird about that. So again, just trying to get clues about even where to look for what we have for bugs here. If I pull out and we look at what happens when I, for example, jump up there, you can see too that it definitely it basically like counter moves the direction you would think it should move, right? The center of the lighting region should be around this, and it actually goes the opposite way it would need to go to get there, right? And if you look at what's happening in here for chasing the chunk origin, I don't see why that would actually be the case. You know what I mean? In here for the voxel cells per chunk call, we're just producing how many voxel cells you move for every world chunk. In here, we're saying when the origin moved, it moved from here to here. So this is the number of chunks you would go if you were walking in that direction. Now, granted, that kind of seems backwards to me, like I said. So that's if I was standing on one and I wanted to walk to the next one, that's where I would go, right? And that seems backwards because actually when you're going to shift for the origin, you want to invert that. But I guess because this was inverted, because this is getting inverted, that's what's happening, I guess. Now, since I don't actually know that, I want to, again, just investigation-wise, I want to see what happens if we do an opposite movement. And then I kind of want to work this out on paper. I'll do it up here. Should probably add an operator negative there, but. And again, this is just for me to try and figure out, like, are we doing this backwards or aren't we? And then I want to write it out to figure out, like, what the heck? And again, it's just, yeah, I'm so confused. I literally have no idea what the heck's going on. I'm totally lost. So let's go ahead and start from square one and see if we can understand what the heck is happening. So here's the 588, here's the day 588 Blackboard. And like, this is just like, what is happening? So again, this is why origin centers are so difficult to do. You can see why everyone just wants to throw everything into doubles. But I actually find it's pretty good to work these through because these are the kinds of problems you should get mentally flexible enough to handle. Plus doubles are slow. Anyway, so if we actually look at what's going on here, here's what we have. We know that we have a simulation center. And we know that around this simulation center, we have a world that's been constructed somehow, right? So, we've got various pieces of the world that are out here. And, maybe we have a chunk, and the chunk has some offset from the simulation center. And inside that chunk, there's, some floor tiles or who knows what's in there. And one of these floor tiles has lighting, all of them do. And that lighting is lined up with our voxel. So our voxel is somewhere in the world, right? And its location is also based on the simulation center. It's some offset from the simulation center. Okay. So now what's going to happen is the simulation center itself is going to move, right? It's going to move somewhere. So like it moves, off to some location, right? And what's going to happen is the simulation center moves, the offset of the chunk is going to change relative to the simulation center in world space, right? Because this offset and this offset are different. So, we want it to appear to be like in the same place or something. So the actual practical offset for rendering is different. Because in one case, let's say this was S0 and this is S1 and this is the chunk position. So chunk zero's position in the actual rendering pipeline is going to be S0 plus, or I should say, C0 prime is S0 plus C0, and C1 prime is S1 plus C1, right? They're totally different equations here because as you move the simulation center, the offset is going to change completely to render this thing, whatever you're rendering. Even if the camera position is the same in terms of what you see, you've changed the coordinates out from under yourself, right? So they're completely different. All right, so if we want the voxel, right, to be positioned in the same place as it used to be positioned, when the camera changes, or I should say when the simulation center changes. We previously had something like, well, the voxel, and I guess we should say something else here. So this is actually constructing the answer in an absolute space. What we actually render is just these, right? So this is the basis, and the basis goes away because it's just assumed to be 0. You know what I'm saying? This is so hard to even write down what's going on. All right. So if we now want this to slide properly, right, and we want this to align itself properly, we want the voxel to align itself properly. Then when we change one of these, we're effectively asking the same question. We're basically saying okay, we have a V0 prime somewhere, and that was the S0 plus the V0. And now we want to produce a new one, and that's going to be some new offset that gets us to the same apparent visual location, right? In both cases. And so if we want if we want these two things to be the same at the end of the day, we would have to solve this, right? We'd say we want these two things to be equal. And so solving for V1, it would have to be S0 minus S1 plus V0 equals V1, right? So the change in coordinates here plus the old offset is what we would now have as a new offset. It would seem. And that's like where the voxel would end up. That's where the voxel's, corner would be. And so what we're trying to do here fundamentally is we're trying to just account for this basis change, right? And furthermore, like when I look at this, when we do this basis change, I mean, even just thinking about this, it doesn't really make much sense the way I'm doing this even now. So let's take this one step further now that I think about it. So this origin P here is just like where I want to build the thing around. So when we pass in this value, the simulation center value, what I don't totally understand is why can't we need this hot voxel rect to start being centered around the actual origin here. So this origin P that comes in, this origin P offset, right? Minus 05 hot dim. That, we should be able to focus on that, and that should always track whatever we're drawing out here, right? This lighting center bit, right? Because the lighting center, if we take the simulation center, and we get whatever the world camera rec's location should be for its center, and we base something around that, that should always be drawing in the correct place. So that's the first thing we need to figure out what has gone wrong. Because something has definitely gone wrong here, right? This value, when we look at whatever the render offset is, that's what's screwing us up here, right? So yeah, let's figure out what's going on. So if we always do this, where we're just passing the simulation center, what we would expect to see is the lighting region, which is that, to be centered around wherever the simulation center is. And let's draw that too. So where is that thing? Sim bounds, right? So I'm going to push the sim bounds on here as well. And just look at them. All right. So what we would expect to see now, and I don't actually know if we will see it. Okay, so we don't. Okay, so basically we're doing this wrong even before we start. So there's the simulation bounds, right? And here's the lighting bounds. It's just totally wrong. Because this should always be centered. The lighting bounds should always be centered around the simulation center. And it's not. So somebody needs to explain to me how the heck that's happening, right? So our problem extends well beyond what I thought it did. We're off in no man's land here. So when we do begin lighting computation and we push the hot voxel rectangle, out here. So this is somehow garbage, right? And I don't understand why. I literally have no idea why this is wrong. Because in theory, that should be centered about the same location that the simulation center is, because it should just be drawn at the same location, right? So how is this possible? What is happening? It doesn't make any sense. So In this case, it's interesting. Our rect center dim, this is actually not using the offset of the sim bounds. Is that actually wrong, for starters? Because in theory, the sim bounds, like, yeah, you know, in theory, the sim bounds would take the sim location offset, right? It's not ever supposed to be, at least I don't think it's ever supposed to be anything other than 0, but we should verify that at the very least, right? Oh. Well, to be fair, why is it camera dot simulation center? So, yeah, maybe we've just got too many variables in here meaning different things. Because when we come through this code here, we create a simulation center that we actually use for the world sim. What are we passing to that? Right? So here's begin sim, and it is passing world mode camera simulation center. So, I mean, that's the right thing, right? I mean, if you actually look at what's happening. So, we just double check. But that should be 0 anyway, so I don't think that should have done anything. Yeah, and it didn't. So if this rect center dim is, if it's centered around here, we know that we're passing that literal value. Like, that is literally the value that is getting passed down. Exactly, right? Is there an offset applied to this render group, perhaps, that we're not understanding? I mean, I guess that could be. But if there was, it would be the same. It would be applied here as well, right? So that doesn't really make a whole lot of sense either. So if we then move and say, all right, here's the sim bounds. We know the sim bounds is just a rect center dim where it does, you know, it picks the center. This should be 0. Yeah. I mean, I got nothing. Those should be exactly the same. The centers of these two rectangles should be exactly the same, right? So let's try one other thing just to see if we're just off in this. Like, I mean, I don't know I have no idea what's going on right now. Might as well be someone else's code base at this point. So let's just try a rect center dim. And we'll say, all right, the rect center dim is just going to be the negative p, or so the center point we're doing here. And then we just are going to make something that's just like 1 by 1 by 1. So we're just drawing like a little cube, right, at the center that we think we are. I'm going to have to make it a little bigger, I guess. Okay. So there's my center cube. It's totally garbage, right? It is not even remotely centered around the simulation center, even a little bit. So now I'm going to take the exact same piece of code, right? Like literally the exact same piece of code. That's the hot voxel rect, right? I'm going to take the exact same piece of code and I'm going to move it out here. So I'm going to do push volume outline. I'm going to pass the negative simulation center. And yeah, I'm just going to literally call that code. And we're going to see where that ends up. All right. So that is actually in the wrong place as well. Yeah? Yeah. Okay. So basically the problem is the this negation. I think that's all there is to it. This is supposed to be putting you at the correct offset from the camera. We're negating it for no real reason, I guess. We just threw a negative in there. I don't know why. So if we draw the sim bounds, and then we draw, I don't need this anymore. We draw the rect center dim at this offset, which is actually putting us into the correct location. That should draw it in the center, would be my argument, in theory. Assuming I actually draw it. Okay. At least now we're back to sanity. So that's fine. So that means the Vox min corner hot was always incorrect. This was not supposed to be there. Which I don't think really necessarily should have made a difference. But the weird part is, I guess I hadn't been considering the fact that it would actually contain some content. And I guess it does, right? What I'm not sure about is that we actually want to use that, though. Because if we use that, that's sliding continuously and we'll be wrong. But I'm going to put that in for a second anyway, right? So if we get rid of this and change this to not having the negative, I'm going to go ahead and draw all our rectangles again. I think we have found the rogue negative that was causing us problems. Okay. So now when I move around, at least in theory, we should have things more centered at the moment. And let's see if we actually do. So yes, there's the lighting voxel, there's the sim region, and they are basically the same. Now, I'm noticing that actually the sim region is narrower here than the lighting voxel, so I guess that doesn't really make any sense, and we should probably trim that down. I don't really know why or how that's happening, but you know, maybe that we should actually widen the sim region. I'm not sure. Doesn't really matter. Anyway, if you take a look at what's happening here, as I'm moving around, those two are now nicely in lockstep. So thank God. That was just a momentary, errant negative ruining our day. So now if we actually want to figure out where the Vox min corner is going to be, we should be okay to now pass down a moving value, right? So now as we move, I think we should be able to allow this to slide. Yeah, and we can. Right? So you see how the lighting voxel is now sliding along? It seems like it is, right? And that's good. However, it's weird to you that we get that weird sampling error. But however, you'll notice we also do still have a weirdness here, which is that our lighting voxel is still not centered the way I would think it should be, right? It's not centered around this. So what's happening? So let's narrow down to that now, because that's the next part of this problem. So now if we say, look, we want to center ourselves around the world camera rect instead, this should allow us to do that, right? By figuring out where that actual center is, I would think. And I guess the problem is, in order to draw this, we need to know what the offset is from the actual simulation center, right? So I guess this is mostly a drawing offset problem. So if we then say, here's the lighting bounds like this, what we want to now do is this needs to kind of be drawn out here, right? And it needs to be offset. It needs to be subtracted so we know where it actually is, right? So the hot voxel rectangle in this case now, yeah, well, I guess we can still draw it in here because I guess this is where it's being set. So I guess we do need one additional piece of information, which is like the sim origin P, which we were getting past before. Right? So this is the thing that determines what we're actually storing as we move around. But then where this actually is in world space, if we want to place it in world space, actually has to be a subtract, right? So it actually has to be this. To place us relative to the world space in order to draw the thing and send it to the graphics card. So we just didn't have actually the information we needed to begin with. I guess that was just like, yeah, not thinking it through. So we need to pass down both of these, the sim origin P and like where we actually want the lighting to be solved. And then we can do the rest of the work that we needed to do. I don't actually remember what this is called. So this requires a world, but we have that. Isn't it called subtract? I guess this is not exposed at the moment. No user-defined conversion available. Sorry about that. I will pass addresses. All right, so now let's get this thing drawing in the right place, which hopefully it will. Looks correct. So that looks correct to me now. Again, the copying looks totally messed up, but at least now the voxel is moving the way that I would expect the voxel to be moving, right? So you can see the camera bounds in the center there, and like the voxel is locked to it. So that's good. So now we just have to figure out how to copy these properly, and then also why we're getting the weird light explosion that doesn't really make a whole lot of sense to me. So something's busted there. Okay. If we now move throughout the world, though, other than that like sort of bug, it seems, which is the copying bug, it seems like at least we're seeing the right stuff. I would point out that we still have some kind of weirdness going on with the simulation region. Like the fact that I don't see, like when you move back here, like the fact that the simulation region doesn't slide forwards as fast as, or maybe the simulation region just isn't as large as it should be. You know what I mean? So it feels like the simulation region needs to be expanded a little bit. Like one more room in that direction. If we take a look at the, where we do the sim bounds. In here. It feels like this or something is not quite right. And I don't really know the best way to fix that, but maybe this. So now the sim bounds are expanded a little bit there. And I just wanted to do that to make sure that like we have enough of the simulation region always loaded in around the player, which seems good, right? So there we go. All right, so now we have the question of why are we getting this weird like copy error? And it seems like at the moment The primary problem again is the the copy seems to be mostly having, well, actually it seems like it's always wrong. It seems like it's not copying for this camera slide at all, right? All right. So anyway, let's go ahead and finish up what we're doing here. So this camera slide now has to be actually prevented from doing a full slide, meaning this subtract has to actually only happen on, it has to be zeroed out to the chunk boundary. Now, that doesn't seem particularly hard to do because, in theory, the origin P here now can just be truncated down. So, for example, we could just say, like, the origin P offset is 0 or something, right? And I think that would lock this to moving only per chunk. So now, as this moves, right, I think... Yeah, you can see now it moves kind of discreetly, right? The problem with that is, again, so now we've gotten to the point that I was wondering about before, and it looks like the answer is, yeah, it doesn't really work. And that's that, like, the chunk granularity is probably too low. Like, we probably need it to do the lighting on something tighter than that. You know what I'm saying? So that gets us back in the business now of saying, all right, now we actually have to look at voxel centers as well, which is pretty annoying, right? But that's what we're going to have to do. So what we're going to have here is like a secondary offset that tells us how much, because it looks like actually that now is working properly, right? To a certain extent. I mean, it's hard to say, but looks roughly correct. I'm not seeing those... I'm not seeing any lighting bugs other than when we're catching up to the lighting region, right? Like the rest of the lighting doesn't freak out. You know what I'm saying? So I think all we really need to do now is just track that offset correctly, and then I think we're in good shape. So it seems like we have like weird light leaking bugs though. Just yeah, there's interesting things that happen with the lighting where like it gets over bright. So we've got plenty of stuff to debug here, but at least the copying seems okay. We can sort of narrow in on all the bugs as we go. All right, so that seems pretty good. And so the question now is, how do we get something more granular? So basically, we don't really want this offset to actually drop to 0 here. That's not good. So what we need to do is we do need to do the thing we were talking about before, where we need to say, like, okay, whatever this origin P is that we're getting in here, this actually needs to be sort of truncated down to some other thing, whatever that other thing is. We need to do this more often than just when they're in the same chunk. So it's true that we need to do it when it's true that we need to do it whenever the center does move, but we also need to do it whenever the origin offset part changes sufficiently to produce a different offset there, right? And I'm not sure... I'm not sure exactly how to make this work out properly. So we need to do basically the same thing we were doing before, which is to say that, like, The origin P offset should drop to 0, and we should just save whatever it was, probably, right? So we probably just want to keep this and then remove it from further consideration entirely. The camera offset then needs to go through like the D camera offset bit. So this is actually going to be, you know, the Hadamard product of the imceldim. So we're going to say, look, how many of these are we actually going to do? And then we would do our round. So this is how far the camera is offset based on what we got told. We then want to do our delta from there. So again, we would probably just do this. And we would have our dvoxel up here. So in theory, this should not do anything different now because we're really not changing anything. So if we just sum in the change for the center, we should be okay. Yeah. So that all looks fine. And so now we just need a way of accounting for this camera offset, and this is what we were doing before. Now, this camera offset is, again, like how far in addition we would have to move besides just accounting for the change in where the chunks actually are, right? So we need to move this far. We need to slide the voxel this much over as well. So if that's our camera offset in voxels, I guess this is like, I'm going to call this vox camera offset, I guess. And then I'm going to actually produce a camera offset, which is the vox camera offset times the celdim. So basically just getting the exact same value back, but truncated to the nearest voxel cell. So now if I say where the min corner actually is, we would say it's at this location plus the vox camera offset minus the centering, right? What is the problem? All right. And that's not vox camera offset. That's just regular camera offset. And we're good. All right. So now we're not actually sliding the voxel. We're just drawing it in a different place. But we're going to see if we're drawing it in the place we would want to draw it, right? Yeah. So it looks like now it's properly following, but we're not actually moving it, right? So we're not doing the dvoxel stuff properly at all. Like the dvoxel's totally busted. So it's not copying the lighting. But at least now we're not off in like, you know, no man's land where we are not even sure why the rectangles we're seeing on the screen are where they are. Like we've actually like got that down, right? All right, so now we need to like, okay, if we're going like forward with this camera offset, we need to slide the voxel. So we need to slide the voxel back one, right? So we need to, when we do this, we need to know that we've changed this camera offset. Now I have to think about how that interacts with this because I don't really know, but I feel like it should just be the same all the time, right? I feel like we should just be able to do this and say if the camera offset went forward, we need to go backward. Would be the way I would think about it, right? So I think that just means we can use the same solution we were doing before, although I need to think about this. So again, it's fetching from the plus. So if we are moving forward, we need it to go backward. This is so confusing. So we know that block copy voxel, let's just take the x direction. So if block copy voxel is going to be fed a value of 1, then what we will see happen in the voxel is a movement to the left, right? Because each cell will grab the one to the right of it, which will look like everything is moving to the left. So an output value of positive x produces a negative x motion, right? So we are going to move our camera offset. Let's say it was itself moving in the positive x direction. So it's moving to the right. So the new one is higher than the old one, meaning the subtraction you would normally do would produce a positive value. As it slides to the left, as it slides to the right, it's moving the voxels with it to the right. So they need to be slid back slid back in the left direction to count for that. So I think it's right. I think. That's all I got. Who knows? So I think that slides the voxel to account for the motion that's occurring there. But no promises. This is just too many things to keep in your head. Yeah, and that worked properly, right? All right. So it took us a long time to get there because, man, that was confusing, but I think this is right now. I'm going to go turn off the debug drawing of those light maps. And also, I guess I'll turn off some of these volumes. All right, so this is now what we would expect to sort of see in game in terms of the lighting, and I just want to see if I see any weird errors or stuff like that with the region. So that's looking pretty good now, and basically our lighting accuracy and the computation of the lighting is probably not super great at the moment. But now, you don't see any, bugs with the fact that we have a roving lighting region anymore. It looks pretty reasonable as you're hopping around. I'm not seeing any of those cracks, the lighting cracks anymore, right? It just kind of looks really fluid. And so mostly I think what we've got now is just light transmission equation problems. So why is that light so bright and things like that. So I think mostly what we need to look at now is how to stabilize and make accurate those lighting computations. Because everything else now seems pretty good, right? But this sort of lighting feedback weirdness, it seems like there's some weird errors going on there, and I don't know what that's about. Feels pretty good. I'm liking it. All right, so I don't know where we are on time. Probably about 10 minutes left, I guess. But this is feeling pretty good to me. And again, this also is completely flat cost now, which is nice. Meaning at the moment, there is no cost for light sources because we actually don't even, we can actually turn off the build of the light volume hierarchy thing because we don't even use it. So actually, this means you can have infinite light sources. It doesn't matter. Put as many light sources as you want. You won't pay any additional cost for them. The lighting is a flat fee, if you will. And you can dump as many lights as you want into the scene. Which is good, because I want a lot of that. All right. So... so I think basically I'm going to end that for now. And then next weekend, we'll start to look at optimization of the Raycaster. Get that to as good as we can. And then we'll move from there to light quality. And that, we're narrow. This is getting good. Like, I'm liking the look of this. We need to start putting in light collectors for trees. Like, right now, we don't put any actual light collector in there. Like, we need to basically say, like, hey, there's a light collector there, which is pretty easy for us to do. And right now we don't. So like light can't bounce off trees at all at the moment. You know what I mean? Which it probably should. Also, we're not properly setting the color of like walls and stuff. So we got some work to do on what we feed in to the lighting system that would make a pretty big difference in quality as well. Looking really great though. I mean, I'm loving the look of this. I would like to smooth out the way, like I would like to make this look a little bit more radial, which I also think we probably can do if we want to. Using a little bit more, the way that we're blending voxels together could probably be changed to produce a more pleasant look there. So we probably want, but that's a pixel shader thing that doesn't really have anything to do with the lighting scheme. Also, we now have specular as well, so we probably want to find a way to take advantage of that, meaning we can have surfaces that appear kind of shiny, and we probably want to have some way of getting that into the game. But anyway, let's do Q&A. How can we disable lighting for the debug UI? Oh, well, it sort of is at the moment, but only because someone requested a hack for it. So, like, at the moment, it actually is, but the reason that it is because someone just was like, well, since the Z is weird, just use the Z. That's not a particularly good solution, but it already is doing that. I think the better way to do it is just have that pass turn it off. So there should just be a thing in the render that's like, this is the lighting is only on for this pass, and it just uses a different shader. Wow, really? OBS is skipping frames due to encoding lag? Are you sure about that? How sure are you of that? Like, at least on OBS, it does not list any dropped frames. So it I don't know, like is it possible that OBS is just doing something like stupid, like it's, it's or not stupid, possibly intentional even. Is it possible that like OBS is sending out like a lower quality stream to Twitch but recording a good one locally or something like this? Oh, okay. So basically you're saying go to uh, view stats. Oh, youch. Yeah. Skipped frames due to encoding lag. 4.4%. Hmm. I'm not sure how to fix that. No, the game is not fighting OBS for the GPU because it's running on a different machine. Uh, there are two separate machines. The streaming machine is actually it's just that. It's the only thing it's doing. Um, so I mean, you know what the problem might be here is that it has to do two encodings. Like, there's a streaming one and like a recording one, and I wonder if there's a way to tell it just do one thing and send them both out. Um, I actually don't know how to tell it to do that. To be honest, um, yeah, I don't even really know how to tell it to not do that. We'll have to look at that a little more carefully. Um, so I don't really know how I would get OBS to not drop frames. I mean, the other thing too is it's the thing is I'm doing it at 60 frames a second, which I wasn't doing before. So it's recording at 60 frames a second, and streaming at 30. And maybe you just can't. Maybe you can only record and stream both at 30, and otherwise it's not fast enough or something. I read a Twitter conversation from an engine programmer who did software about the engine for a new Doom game not having a main thread or render thread, only tasks and queues. Could you comment on this architecture? Yeah, that's kind of more or less the standard architecture. I would say that so you do need to, like, you can't use OpenGL, for example, if you want to do that. It doesn't work. You can use D3D, or I think they use Vulkan. They might use both D3D and Vulkan. I don't know which ones they use. But OpenGL doesn't really work, if that makes sense. And so I guess what I would say is, as long as you have the ability to do things like allocate graphics memory from more than one thread, this works okay. If you don't have that ability, then you're just kind of screwed. And OpenGL multi-threaded just doesn't work. It's not because it couldn't, it's because it doesn't, if that makes sense. Like the drivers just are too buggy. Well, no, but like, so Valbus, the thing is, like, looking at the stats on, the actual OBS, it says skipped frames due to encoding lag is 4.3%. So it's just not fast enough at encoding this video. It's just, I don't know why. What's weird, though, is that, like, if I watch the number, it's at 2617 right now. And if I start hopping around like so, you can see it goes up only when the screen goes up. So it's literally just the act of having too many deltas per frame is the thing that causes it to miss. And again, I really don't know what to do about that. Let me see what's going on CPU wise. I think the problem is this machine doesn't have a dedicated GPU that could really be used for this, so it's entirely CPU based. And if I look at the CPU usage, it is pegged. Like OBS Studio is basically just using like 100% of the CPU and 30% of the GPU at all times. So like I don't know what it's having trouble with, but again, like video encoding is kind of expensive, like MoComp specifically, checks are expensive. So I don't know. If I look at the if I look at it, it's probably the recording. I don't know. I also don't know why, like, is there a reason that there isn't a frame rate on here? It looks like you can't set two different frame rates. So there's only 60. So I think the problem is it's having to do two 60p streams, and 260 1080p streams is probably just too much for a Core i7. One would probably be okay. But I don't know how to tell it to just stream the one. Like, I don't know how to tell it, like, just do one and stream it. Isn't that, like, wouldn't that be a button here somewhere? I don't know. Maybe there's a way to do that. But I don't see it. So I got nothing. So it might be possible that you can do that. It might not be. And I'll just have to, I don't know. Or we just live with it. I guess another question is, I don't know if I go look at the recorded video, is the recorded video actually okay? Like, this is not really telling me much about, this isn't really telling me much about the difference between those two things. So I don't know. You once mentioned that there are two types of GPU, tiled and non-tiled, and mobiles use tiled method, but why? What are the benefits for mobiles using it? Well, actually, kind of everyone uses tiled to a certain extent. It just depends on how tiled you are, right? But the idea behind tiled rendering is just that if you don't have you could think of it as being exactly the same as why you do it on the CPU. If you have a very strong caching architecture that allows the cache to kind of suck up any kind of weird access pattern problems that you might have, and everything just works fine, then you don't have to really worry about a lot of locality stuff. But if you have a limited ability to do things like caching, or limited ways of accessing the cache, or limited amount of memory to use for stuff, etc., the reason that you want to move to tiled rendering is because if you keep everything in one tile local to like one processing unit on the GPU, then there's just a lot less communication that has to happen and a lot less cache missing that has to happen, right? Think about a pretty simple case where you want to rasterize two different triangles, right? And I hand one of those triangles to one processing unit on a GPU and another triangle to another processing unit on the GPU. This is not how it actually works, but I'm just giving you an example. Well, if those two triangles are actually in completely separate locations, this works just fine, right? If these two triangles are in the same location, we have an issue because one GPU processing unit is trying to write to stuff that another GPU processing unit needs to write to first, because the triangles go in order, right? And so if I know that all of my triangles that are in a particular location as bound by a tile on the screen are all being handled by the same processing unit, I don't need to worry about that data dependency anymore at all, right? So you can see why, at the very least, you want to break things up into bins on the screen, because if you can do that, you then can eliminate a whole series of inter-core communication problems you might have with people wanting to fill stuff, right? In order. Now, in reality, GPUs have lots of strategies for doing these things. Tiling is one way of reducing the communication that you need and the amount that you have to move memory between different parts of the chip or caches, right? Another way that they often do it is by producing intermediate results and then combining those intermediate results later. Now, if you ever wondered, for example, why blending is not programmable, this is why. On a tiled part where one core is doing all of the rendering for a small region of the screen, programming the blend operation is free, right? You can just do it and it will work because it can just execute code and be done. Exactly like it executes all the rest of the code. On the other hand, if you are doing something where you have a triangle being rasterized by somebody who doesn't yet have the ability to know if someone else who needed to rasterize a different triangle had already done so, right? Then in that case, you need to wait for a special purpose unit to combine those two results in order later. And that unit isn't programmable. See what I'm saying? So you definitely have situations where tiling makes things a lot simpler for you. And the degree to which you can leverage a tiling architecture is like everything else in GPU design. It's kind of just a magic, hey, we keep trying to work out the fastest way to take giant sets of triangles and move them through this chip to produce an output frame, and sometimes the cost of the chip plus the die area plus the caching plus the power consumption rules mean that tiling everything completely is the fastest way to render triangles at this price point, and other times it isn't. Know what I'm saying? So why chips use tiling or don't use tiling is beyond me. You know, it's a GPU design question, but hopefully you can appreciate why tiling changes how things behave, because the degree to which a particular architecture needs to have handling of things like order dependency or needs to understand things like how to move things between caches efficiently and stuff like that can change dramatically depending on how it is ever going to partition work between the elements of the chip. And so if you can make a chip that just knows that all of the things that happen to a particular 4x4 pixel block somewhere always happen on one core of the GPU, well, that's a lot easier than saying it can happen on multiple ones, right? So they make those decisions based on how their architecture can most leverage the cost and the power and the silicon cost that they're going to have, right? Yeah, so Fabian is totally Fabian is like totally describing what's going on for a GPU, right? If you think about the way a GPU works, a GPU knows ahead of time what has to go out to the display. It is handed literally a complete package that is like, here is everything that has to happen to draw this frame. So latency is not particularly relevant to a GPU because it doesn't care when any particular thing comes back. It just wants the total amount of time taken to produce a frame to be as small as possible. So even if there's something at the beginning of the frame that takes all the way till the end of the frame to finish, nobody cares as long as the total frame time was minimized, right? So as a result, and I think this is presumably what Fabian's talking about, I don't know because I'm not sure what you're referring to, but as a result, everything in the actual GPU pipeline is designed strictly around one thing, really, and that is never let an FMAD go to waste, right? So a GPU is a giant set of floating point multiply add circuitries, right? And these ALU units that can do that, we just have a crap ton of them. And we need to, in so much as possible, ensure that at no time is one of these FMADs not producing a value we will actually use in the final frame. Like, the fastest possible GPU performance is 100% of the FMAD circuits are FMADing for something that we actually will use in the frame all the time for the entire duration of the frame. Because that means you literally did the maximum amount of computation work for the visual that you could. Right? So as a result, a GPU doesn't think about things as trying to get the fastest turnaround time for things like a memory access. What it wants to do is just make sure that it can have enough memory accesses in flight at a time so that it can be doing FMADs, and by the time it finishes doing the FMADs it's currently doing, enough memory has come back to start the next batch of FMADs, right? So the entire pipeline is in the GPU is not set up to render one triangle as fast as possible. It never cares how fast a single triangle renders. In fact, a single triangle could take the entire frame to render and no one would care. All that matters is that at no time is some actual multiplier unit sitting around doing nothing. And so they go through extraordinary lengths to make sure that they can pipeline everything so that there's always work coming in. And so forward fetching that work is incredibly important. Like, you always want to make sure that they've got tons of things queued up to do. Because if those queues ever run dry, then an FMAD will go to fetch the next thing to do and it will find nothing. And that is when you have now lost the battle, right? To keep the GPU math pipe stuffed. Why are desktops using non-tiled method? Well, so there's a lot of reasons that tiling might not be the best decision depending on how complex your architecture is, right? So let's take a couple examples. One is that you have to reprocess things. So on every tile boundary, any triangle that spans those two tiles, two people now process that triangle, right? One on the one side, one on the other. A triangle could span several tiles. Many people are now doing work on that triangle, right? Another reason is, well, some things can be tiled, but some things can't. For example, unordered access views. Well, these things are now writing to arbitrary pieces, so we don't really know where they're targeting. And so some feature sets just don't lend themselves to tiling, right? Ray tracing, not tiled at all. Like, that feature is just a pure, like, geometry walk, right? And so the more general purpose the GPU is actually doing, the less amenable it is to tiling. Now, the rasterizer is always going to be somewhat tile-based, right? Because we always know that when we rasterize something, eventually it gets down to something we can bin into tiles if we want to. And in fact, we need to do that to determine what actually gets drawn at all. So there's always some concept of a tile to a certain extent, but the degree to which it's really tiled as a rendering architecture, again, more heavyweight, high-end, super-powered GPUs that are designed for arbitrary processing, the amount to which they can really rely on tiling to be efficient goes down. Not to mention the fact that tiling makes it so that you are only as fast as your slowest tile, is a way to look at it. So things that expect to have really concentrated areas of detail and then less area of detail everywhere else, that also won't work very well with tiling, because tiling requires you to have a fairly flat, equal level of detail across the whole screen to a certain extent. I mean, it's not exactly that, but sort of. So tiling isn't a panacea. It's just a strategy. And the degree to which that strategy has payoffs for you depend a lot on what your workloads look like and what your GPU architecture is going to be. The new COD Battle Royale installs shader for better game performance when being in the game. Can you imagine what I'm sorry, I don't really know what that means. It might not be installing the shaders. So what you have to understand is a shader is a program, much like an executable is a program, yes, but it can't ship precompiled. And the reason it can't quite ship precompiled, I shouldn't say precompiled, but precompiled and linked. And the reason it can't be shipped that way is because the shader itself doesn't know which hardware it's going to run on. So it might run on this particular piece of Intel hardware, it might run on this particular NVIDIA hardware, right? So the shaders have to actually be compiled for the card, the chip on which those shaders are running. If you have an engine that has a festival of shaders, so there's like 1,000 shaders used in this game because that's the way they did it, right? What normally happens when you're playing the game is every time one of these shaders needs to get activated, it has to get compiled first, right? And that can actually cause your machine to suffer a performance degradation because now the like compilation of that shader is actually taking machine resources, right? So what you can do if you care a lot about this problem and have it is during your install, you can say, oh, what is the GPU that's currently there? And let's go ahead and ask the GPU driver that's installed in the machine right now to compile these shaders now during install, and we'll just save what it produces as the binary blob of the shader, right? And then at runtime, when we need to activate that shader, we can just literally hand it the pre-compiled, optimized version that it already had plenty of time to chew on, right? And so I don't know, because I don't know anything about Call of Duty. I don't know anything about the team. I have no idea about the engine, and I've never even played it. But one thing that might be happening if someone says it's installing shaders is they might not be installing the shaders so much as they are compiling the shaders for you so that doesn't have to happen when the game's actually running. But that's just a guess. I have no idea. So Valbus, no, there are actually no current ways of compiling shaders on any API, period. What actually happens is that you can pre-process a shader into an IR, and there's two of those. So one is SPIR-V, which is Vulkan and OpenGL, and one is like D3D assembly language, quote unquote, right? So you can do the first phase of compilation, which is like the text processing and turning it into like an intermediate representation. But there is no way to pre-compile it all the way. And so what then has to happen is, say even on OpenGL, this is the way it works. When you're actually on the machine in question, when you're on the actual GPU you're running on right now, then you can ask that, compile this for you, and you can hand it the intermediate rep or just the raw shader code. It will compile it for that card, and then you get back a binary blob. That binary blob will only work on literally that card. Like, yes, it may work on another very similar card, maybe, but the driver's under no obligation to do that, and it certainly won't work on like a different manufacturer's card or anything, right? Does that make sense? So OpenGL does have a way to say precompile the shader, but it precompiles it for a card, the card you're running the OpenGL thing on right now. So you can't ship that shader. It wouldn't work. It would fail on most people's machines. So that's why you need to do it at install time. Now, if you know exactly what you're installing on, so, you know, like a PlayStation 4, well, there you can precompile your shaders because there's only one thing it could be, right? But that's the minority of the cases. Almost everything you ship on these days, you have to compile at the time you're actually on the platform. Oh, Team R&B, I'm not sure what our frame rate is right now. It's you know, I'm still, you know, thinking we have to do some pretty hard optimization work based on where we're at. Because we'd like to get that down to at least 30 milliseconds. And, you know, if we're feeling really saucy, we want to get it all the way down to 15. So we're going to have our work cut out for us, to be sure. However, you know, like, I don't know that it's impossible. Like, I think we, you know, I think we've got a good shot at it. So I also don't know if we need the lighting region to be this big. It seems like, based on what I'm seeing, that we could shrink the region a bit and bias it forward slightly and probably narrow the region quite a bit. Like if we're looking at this, you know, this whole area back here is never visible, right? So we could probably shift the area forward a few voxels in Y and reduce it just in general, the total size, because, you know, looking at it, it's lighting a lot more than it needs to. So, you know, could we get away with a much tighter voxel? I think we probably could. And I don't know exactly what the, you know, the tightness of that is and where the artifacts would start coming in, but I could see something maybe even that aggressively small as being theoretically feasible if we tighten the bounds up, you know? So looking at something like this, right, and how that scrolls around, again, we would probably want it to be biased forwards a little bit rather than backwards. So, you know, inside the Voxman corner, in the shift here, what we would generally want to do is say, like, look, whatever we're getting for the camera offset here, we're going to have a Y bias where the bias for the look, like where the Y is actually located relative to the camera center is always going to be shifted like up a little bit. So, you know, we're going to go like 2 cells forward or something like this. So it's always just a little bit up. So that it has a little bit more look ahead. That's just because of the way the perspective is shifted, right? And if we did something like that, then I'm not convinced we couldn't get away with something like this small. Again, it's hard to say exactly, but, you know, it doesn't feel like it would be a stretch to say that that's a tight enough bounds on the voxel, right? And who knows? We'll see, I guess, right? And if you look at how fast that's going, that's already at 30 frames a second, basically. And so if we figure we maybe can squeeze some more performance out of the way that it's working, I could see us getting to a reasonable 30 frames a second or 60 frames a second hit there without a lot of stress. Could you recommend some resources about GPU architecture and strategies to dig deeper? Not really. I don't know where those would be. You'd probably have to go look at Fabian's blog. I don't know. Could be easier to not have this dimension to define. Well, the problem is I don't want the frame rate to vary based on where you are. So I'd rather have the lighting be a fairly fixed cost. What do you think about the new kind of pipeline that NVIDIA is pushing with mesh and task shaders? I think it makes a lot of sense because I think GPUs and CPUs are kind of converging to a certain extent. So I think moving to something more like a CPU model is probably where that has to go long term. Shimar B, if we had a major light source from behind and we had, say, a large tree house behind us, if this light box is too small, would it mean we would not get the shadow of whatever is behind us? No. So the lighting as it exists now, it computes probes in certain locations, but the lights can be wherever you want them to be, and the shadows can cast from wherever you want them to be. So all it would mean is you wouldn't get secondary lighting from over there, because the secondary lighting is only produced when you grab something from a when you grab something from a secondary bounce, that requires you to be inside the voxel. So secondary bounce lighting from outside the region will not contribute. However, I don't know to what extent that would ever affect us because secondary bounce lighting is fairly weak. So the chances that you could actually have a significant difference there, it seems pretty low. Is it possible to make the 2D trees cast shadows in the shape of a tree on the ground? So I guess the answer is like, yes and no. it's possible to have the 2D tree cast a shadow on the ground that will look exactly like the tree actually is a 2D cutout card. Right? So it will not look right at all. And there's literally nothing you can do to make it look right because the place where the tree and its shadow meet, you can't really orient that to look proper, probably. You could try to warp the tree a little bit, right? But the problem that you fundamentally have is like the same problem that we have in rendering. Like, you know, when you look at what would happen if I started to try and look at these trees from a different angle, you see what they look like, right? They're just cards sitting there. And so we're orienting them at the camera to make them look okay. But the light is going to come from a different angle. And so if you want to cast a shadow, you'd have to like lie the sprite down on the shadow, and then you'd have to kind of like figure out what to do at the base so that it didn't produce an offset. I mean, it's ugly. So it's why we don't do hard shadows. That's why we're not doing hard shadows in this game, is because hard shadows on sprites, I don't think they look very good. So would solving the lighting wrapping in X reduce CPU load to a significant extent? I don't think light wrapping in X has anything to do with CPU load. Would you consider using compute shaders for some of these lighting calculations? Not really, because we're trying to keep it fairly straightforward and not using compute shaders. Compute shaders almost never work also. They're extremely buggy and error prone. So you invite a lot of compatibility issues if you use compute shaders and try to ship that. So if we were going to accelerate the lighting, I would try to phrase it as a straightforward shader, meaning something that can be done as a pixel shader, not as a compute shader. And to be clear, I don't think you would need a compute shader, because in order to do generation of the voxel, you shouldn't really need to use a compute shader, because you know you're updating each individual voxel piece at a time. You shouldn't need the arbitrary nature of the compute shader, really. So if we were going to move this to the GPU, I wouldn't use a compute shader unless I found I really somehow couldn't do it otherwise. All right, I'm going to wrap it up. Okay, thank you very much for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. If you want to follow the series at home, you can always pre-order the game on handmadehero.org. And it comes with the source code so you can try out your own stuff if you want to experiment with it. I'll be back here next week when we'll look at optimizing the raycasting engine and trying to get it up to a faster speed and maybe more rays per second, just in general. So even if we want to stay at something like 30 frames a second, we can at least improve the quality of the lighting and so on using more rays. And then from there, we'll just move into lighting quality territory and try to figure out how to make sure that our lighting is always making sense. And that'll require some analysis of all the things we're computing to make sure we're not doing anything that adds energy to the system in the wrong way and things like that. That's it for now. Hope to see you back here next week. Until then, have fun programming, everyone, and I'll see you on the internet. Take it easy, everybody.